Very soon, you'll be writing Physical Sciences, Paper 1, Paper 2, Life Sciences, and Geography. For study notes and past papers, go to allpastpapers.com. allpastpapers.com.
Let's go ahead and take a look at question 6. Question 6.1 says, prove that whatever is given is equals to the right-hand side. So we're going to choose the left-hand side. We're choosing the left-hand side because that's where more trig ratios are. So the left-hand side is equals to, we have tan of 180 minus x into 1 minus cos squared x plus cos squared x. So we can agree that 180 minus x is found on the second quadrant and tan is negative on that quadrant. So we're going to have negative tan x being multiplied with 1 minus cos squared x, which we know to be sine squared x, and then we have plus cos squared x. So now let's change negative tan x to be cos and sine, right? So we're going to have negative sine x over cos x, which is being multiplied with sine squared x plus cos squared x. So let me get this. Okay, so we're going to have negative sine cubed x divided by cos x. We're going to add that with cos squared x. So I want us to lead cos squared x into having a denominator which will be cos x. That means we will multiply cos squared x by cos x over cos x. So let me show you what I mean. I mean negative sine cubed x divided by cos x plus cos squared x multiplied by cos x over cos x. So you're allowed to multiply anything by 1. So cos x over cos x is equal to 1. That is why we're able to multiply by it. So the reason why I'm multiplying by cos x over cos x, it is because I want this part here to also have a denominator which will be cos x, so that I can put the two terms above one division line. So we're going to have negative sine cubed x over cos x being added with cos cubed x over cos x. So that will be equal to negative sine cubed x plus cos cubed x all over cos x. So that will give us cos cubed x minus sine cubed x all over cos x. So now if we look at our numerator, we know that if we have a cubed minus b cubed, we can factorize that using the difference of cubes. So we're going to have a minus b into a squared. So we're going, for the second term, we're going to multiply a by b, but change the middle sign. So it means that we're going to have plus ab, and then the last term should always be positive. That means we will have plus and then the b squared. So we're going to factorize this using the same rule. So that means we're going to be left with cos x minus sine x into cos squared x plus sine x cos x added with sine squared x. So that means we're going to have all over cos x. So that means we're going to have cos x minus sine x, and we're going to multiply this by this bracket here. But if we look at that bracket, we can see that we have cos squared x plus sine squared x, and we know that cos squared x plus sine squared x is always equal to 1. So we're going to have 1 plus sine x cos x all over cos x. But if we look at our first bracket, which is this one here, we can see that on the right hand side we have sine sine x, which is positive, and a negative cos x. That means we're going to remove a common factor of -1. So we're going to have negative into, sorry, let me use this. So we're going to have negative into sine x minus, not positive. So we're going to have sine x minus cos x into 1 plus sine x cos x, and then we're going to divide the whole thing by cos x. So that will be equal to sine x minus cos x into 1 plus sine x cos x all over. So we can take this negative into the denominator. It will not change the product or the sum up of everything. So we're going to have negative cos x. And then we're going to say therefore left hand side is equal to the right hand side. Let's move on to 6.2. 6.2 says it is given that sine squared x and cos squared x and 1 over 2 sine 2x are the first 3 terms of an arithmetic sequence. The constant difference of the sequence is not 0. Determine the general solution for x. So we know that d is equals to t2 minus t1, but it is also equal to t3 minus t2. So we're going to have t2 minus t1 being equals to t3 minus t2. That is general knowledge, or that is something that we already know for arithmetic sequence, right? So t2 in our sequence will be cos squared x, and then we're going to subtract t1, which is sine squared x, and then we're going to have that being equal to 1 over 2 sine 2x minus cos squared x. So if we have that, we will take everything into one side so that we can have the other side, or so that we can have everything equal to 0. So that means we're going to have cos squared x minus sine squared x plus cos squared x minus 1 over 2 sine 2x being equal to 0. So cos x plus cos x, that will give us 2 cos squared x. Sorry, it's cos squared x plus cos squared x. And then we're going to have minus. So if we have 1 over 2 sine 2x, we know that this will give us 1 over 2 into 2 sine x cos x. So that means we'll be having sine x cos x, because these two will cancel up with that one, right? So we're going to write sine x cos x here. So we're going to have minus sine x cos x, and then we're going to have this, which is minus sine squared x is equals to 0. So we now need to factorize this. I do not know how you were going to factorize it, but let me do it how I would have done it. I would have had 2 cos squared x minus 2 sine x plus sine x cos x, sorry, and then I will have plus sine x cos x minus sine squared x being equal to 0. So I separated our middle term, which is this term here, in such a way that I will have a common factor of 2 cos x with this term and this term, and then I will have a common factor of sine x with this term and this term, right? So let me go ahead and factorize that. So I will have a common factor of 2 cos x into, so if I remove 2 cos x, or let me like put that in brackets so that you can see what I am doing. So I will have this bracket here and this bracket here, right? So with the first bracket, we have a common factor of 2 cos x. So we'll have cos x here minus sine x, and then we'll close that. And then for the second bracket, I will have a common factor of sine x, right? Let me add sine x there, and then I will open, and it will be cos x minus sine x being equal to 0, right? So Oh, some of what I have written got erased. But either way, so I will have cos x minus sine x as the common bracket, and we'll have the rest here. So that will be cos x plus sine x. So this will be equal to 0. And now I'm going to have this bracket being equal to 0 or this bracket being equal to 0. Just how you solve it when you're solving for x, right? So I will have cos x equals to sine x, or let me write that step by step. So I will have cos x minus sine x being equal to 0, or 2 cos x plus sine x being equal to 0. So with this one, I will have sine x being equal to cos x, won't I? And then for the second one, I will have sine x being equal to negative 2 cos x. So for my safety and to avoid losing marks, I prefer dividing by cos x, dividing by cos x. So I will have tan x is equals to 1, or, and then on this side I'm also going to divide by cos x, divided by cos x. So I will have tan x being equal to minus 2, right? And then if I do tan inverse of 1, I will have my x being equal to 45. So I will have x equals to 45 degrees plus k 180 degrees. So I will have k 180 because the period for the graph of tan is 180. And then I will have or, and then tan inverse of negative 2, that will give me x being equals to negative 63.43 degrees plus k 180.